Welcome to my YouTube channel. In this video lecture, I am going to answer questions from basic radar chapter, and the resource or the book that I am referring to is Ground Studies for Pilots. So I am going to answer questions from this book. The name of the chapter is Basic Radar. I have already solved questions of basic radar principles from Quick Williams Radio Nav and Oxford Radio Nav books. So do watch those lectures as well. Let's begin now with question number 1. A radar transmission has a pulse width of 2 microseconds. What is the minimum resolution distance in range? Okay, so you have to remember this fact that radial resolution depends on half pulse width, half the pulse width, and azimuth resolution depends on full beam width. So radial resolution half the pulse width and azimuth resolution full beam width. So here they have given us a pulse width of 2 microseconds, and they have asked us to find out minimum resolution distance, minimum radial resolution. So the minimum radial resolution, the answer will be minimum resolution distance in range will be equal to half the pulse width. So what is the pulse width given to us? 2 microseconds. So half of 2 microseconds, which is 1 microseconds. Now 1 microseconds in terms of distance will be equal to 300 meter. Remember this, 1 microsecond equals to 300 meter. 1 microsecond equals to 300 meter. So you will select the option that has 300 meter. So very important, this is a picture from a Radio Navigation Oxford book. So the very important point, radar resolution depends on two factors: radial resolution, half the pulse width, and azimuth resolution, full beam width. Remember, and here it's given that 0.5 microseconds equals to 150 meters. So 1 microsecond will be double of that, that is 300 meters. Next, what maximum detection range would you expect from a radar transmission whose pulse recurrence frequency is 1 kilohertz? So use the formula: range is equal to speed of light divided by 2 into frequency. So substitute the values now. 3 into 10 raised to 8 divided by 2 into frequency is 1 kilohertz. Now 1 kilohertz equals to 10 raised to 3 hertz. So multiply that by 10 raised to 3. All the units must be SI units. So range will be equal to 1.5 into 10 raised to 5 meters. 1.5 into 10 raised to 5 meters. So range will be equal to 1.5 into 10 raised to 2 into 10 raised to 3, that is equal to 150 kilometers, or 150 kilometer will be equal to how many nautical miles? 150 divided by 1.85, which is 81 nautical mile. This is how you do it. Next, a ground radar with a frequency of 10 gigahertz would be used for what kind of equipment? Terminal area control and surveillance, airways monitoring, precision approach radar, airfield surface movement surveillance. Okay, so a ground radar with a frequency of 10 gigahertz. So 10 gigahertz would be normally used for precision approach radar. Airfield surface movement will be using a frequency between 15 gigahertz and 17 gigahertz. 15 and 17 gigahertz. Okay, so precision approach radar will normally use 10 gigahertz. Next, azimuth resolution on a radar screen depends on what? Does it depend on pulse width, frequency, beam width, PRF? So remember, azimuth resolution depends on the beam width of the transmission. Radial resolution, like I said when I was solving question 1, radial resolution depends on half the pulse width. Next, what band does a surface movement radar on an airfield use? So a surface movement radar uses super high frequency band. Super high frequency band. Next, question 6. A radar antenna rotates at 15 rpm. It has a pulse width of 2 microseconds, beam width of 3. Two aircraft are flying towards the antenna at the same speed and same range, but separated by 1 miles. At what range from the antenna will the radar first be able to distinguish between two aircraft? Now, for the transmitter to be able to distinguish between two aircraft, these two aircraft must be situated outside the beam width. Outside the beam width. Okay, so this is the beam width that I have drawn, and both this aircraft must be situated outside the range of this beam width. Okay. Next, this aircraft are separated by 1 nautical miles. Beam width is 3 degrees. Okay, beam width is 3 degrees. Now we have to find the distance from the transmitter to this to the aircraft. So this horizontal distance is what we have to find. Lateral distance is 1 mile given to us. So in order to find this horizontal distance, we will consider this one of the triangles out of these two. Okay, let's take the upper triangle and redraw this diagram. So we have to find out this horizontal distance. Now since we have taken one triangle out of the two, now this total 1 nautical mile will be divided into zero point 0.5 and zero point 0.5. So this will be 0.5, this will be 0.5 nautical miles. So I'm writing that here. 1 nautical mile will be divided into two parts, half and half. Similarly, 3 degree will get divided into two parts, two equal parts, 1.5, 1.5. So I'm writing it here, 1.5 degree, right? And there is this aircraft here. So now we have to find the distance from the transmitter to this aircraft. So let's use 1 in 60 rule, which says 1 in 60 rule is angle equals to distance of track upon distance gone into 60. So angle is 1.5 degree. Distance of track is 0.5 nautical miles. Distance gone is what you have to find out. Multiply by 60. So x equals to 0.5 into 60 divided by 1.5. So x will be equal to 0.5 into 60, 30 divided by 1.5. That is equal to 20 nautical miles. So the horizontal distance from the transmitter to this point is 20 nautical mile. 20 nautical mile is nothing but 37 kilometers. 37 kilometers. Remember this. So this ends our lecture. I hope you have understood all the 6 questions that I have done in this lecture. Practice these questions. Practice the questions from Oxford and Keith Williams as well. Apart from this, I have also marked important points from Basic Radar chapter, Oxford Radio Navigation book, and uploaded that video lecture already. So do watch that video lecture and mark the important points. Make notes of those important points. I wish you all the best for your exam. Subscribe to this channel. Share this video with your friends, please. I'll see you next video lecture.